guys. Okay, so welcome to the AMATYC 2022 webinar series. We are with Roxy Peck, the case for better technology in introductory statistics, sponsored by the AMATYC ASA Joint Committee. Rebecca Wong is that contact person. Julie Hansen is here with us as well. So thank you to McGraw-Hill Higher Education as our supporter for the AMATYC webinar series for 2022. And as always, if you are interested in AMATYC, or if you would like to join AMATYC, you can use the QR code or this link right here, and I can actually put that into the chat as well. Remember also that the views expressed by the presenters are not necessarily the views of AMATYC. Commercial products mentioned by presenters are not endorsed by AMATYC. A recording of this will be posted onto our AMATYC webinars page, which will be found via link or via the QR code. It may take us up to 2 weeks to produce and upload this webinar to the archive. Also, just a note that our webpage will be getting an update soon, so just wanted to let you know that as well. We also offer a variety of professional development opportunities for those that are interested, from traveling workshops to our next annual conference in Toronto. So today there will be an attendee survey. It will be posted into the chat about 10 to 15 minutes before the conclusion of the webinar. Additionally, the survey will be emailed to all who registered. If you have any questions or concerns, please email me at the address given. And so today, again, we are here with Roxy Peck. She is a professor, Professor Emerita of Statistics at Cal Poly, faculty member of the Statistics Department for 30 years, a chair for 6 years, nationally known in the area of statistics education, fellow of the American Statistical Association in 1998, and in 2003, she received the American Statistical Association's Founders Award in recognition of her contributions to K through 12 and undergraduate studies in education. She's received the USCOTS Lifetime Achievement Award in Statistics Education, in addition to authoring the textbook Statistics, Learning from Data. Roxy is also a co-author of the textbook Introduction to Statistics and Data Analysis and editor of Statistics, A Guide to the Unknown. And with that, I'm going to let Roxy take over. Let me stop sharing, and thank you again. Here's Roxy.
All right, I saw the Cal Poly comment in the go run by in the chat. Let's see now, where is my? Let's see. All right, let me get going here.
You're looking good.
All right. Well, welcome this afternoon. I appreciate your spending part of your day with us today. What I'm going to be doing today is talking about or trying to make a case for better technology in the introductory statistics course. And just as we get started, I'm going to ask Mary to put up the poll. I'm going to ask you 2 questions just to get to know the audience a little bit better, so I know who I'm trying to make my case to. So you could go ahead and start the poll. There are 2 questions. I'll have you answer those, and then we'll get going.
So everyone should be able to see the poll.
Mm-hmm.
And I've also allowed the panelists to do the poll as well.
Mm-hmm.
So the, oh, that's weird. I don't know why that's not populating. So that should say introductory statistics course. I don't know why it's doing that. That's unusually weird. I love it. Sorry about that. So hopefully you can see here. And so I'm just going to kind of talk about it. And you can even say something if you'd like, Roxy. The reason I say that.
I can't see the results.
Can you see it? Okay, so I'm going to kind of tell you the results.
Okay.
So we still have a couple that are yet to vote. So I'm going to let that finish. Okay.
Mm-hmm.
So currently with 40 of 49, the no technology question. So I'm going to go by what you have it designated. So about 41 people have voted to have done no technology, 8 graphing calculator only, 11 have done your number 3, and 4, 20 people, statistics software or apps is the primary technology.
Okay.
For the second question, if you use statistics software or apps in your course, how do your students use them? Only for data analysis, 6. Only in activities designed to develop conceptual understanding, 7. And both for data analysis and to develop conceptual understanding is 28.
Okay. All right. Well, thank you very much for for doing that. Well, that's interesting. So it sounds like we have kind of a mixed. Oh, now I can see the results.
I hit, there's a thing that says
Oh.
share results. So yay.
Oh, okay.
That's
great.
a new one for me.
All right. Well, yeah. So interesting. So I'm going to be talking to two groups of people here. I noticed that about 25%, about a quarter, are either using graphing calculator only or no technology. So to that group, I'm going to be hoping to make a case for why you might want to consider using better technology or different technology in the introductory statistics course. And then for those of you that are already using statistics software and apps as your primary technology and using it both for data analysis and to develop conceptual understanding. Some of you may already agree with what I'm going to be saying, and others may be looking for ways to try and make the case to your department. That's what we saw. We did a talk similar to this at the AMATYC meeting in last November, and quite a few people in the audience said, I do this, but I'm looking for ways to try and convince my colleagues as well. So I'm going to start by taking a look at some recommendations for the introductory statistics course, because this will be kind of the foundation for my argument here. And these are from the GAZE guidelines. GAZE stands for Guidelines for Assessment and Instruction in Statistics Education. And this is a document that was revised in 2016. It's a document produced by the American Statistical Association, but it's been endorsed by other professional organizations as well, including AMATYC. And this document makes a number of recommendations for the introductory statistics course. You see them listed here. There are 6 in total. And what I want to do is kind of highlight a couple of these for you to see. The first one that I want to point out, because this is something that was also new in the revision back in 2016, is there's a recommendation about giving students experience with multivariable thinking. And what that means is that we need to be looking at including examples that include more than 2 variables, and asking students to work with data sets and engage in problems that have them think about more than 2 variables at a time. So that's one of the recommendations. Another recommendation I want to point out is the recommendation to integrate real data with a context and purpose. And what that means to me is that we have to have data sets that are bigger, that have more than like 10 observations in them. Real data with a context and a purpose implies something more than working only with small data sets. And then another one of the recommendations is to use technology to both explore concepts and analyze data. And so that means to me that we need to be thinking about using technology in a way that's interactive, that engages students with the technology as well. And so I'm going to argue or try and make the case that I can't really do any of this effectively, or these things effectively, if my only technology is a graphing calculator. Right, so if we take a look at the introductory statistics course today, I think that the introductory statistics course, if we see what's happening, it's becoming increasingly visual, and data visualization is becoming more of a focus because it's a really important skill, both for literacy in terms of what what our students will encounter in the media and in also in their professional work, and also as a way of communicating information. And so the kinds of things that our students are seeing today are things like this graph. You can't really read this well, but this graph, it looks like a scatter plot. The bones of it are a scatter plot. This is looking at different models of vehicles, and it's looking at the average cost per month to operate that vehicle, and also the carbon emissions for the vehicle. But it's also added, in addition to just those two variables and a scatter plot of the two variables, it's added some additional variables. One, it's using color to introduce the type of car, so that it distinguishes between electric cars, hybrid cars, diesel engines, and then traditional gas engines. And then there's this one little point over here, out at the end. They had one model that was a fuel cell car. So it's introduced a third variable. And then in fact, it actually has another variable, which is the model of the car. They've labeled a few of the points here, but in the interactive version of this graph, you can hover over one of those points, any one of those points, and see what the model car is. And so this is the kind of thing that students are looking at that really pushes them beyond the, just the bare bones scatter plot that we often do in the introductory statistics course. They're also seeing things like this. This was from a newspaper that appeared in San Diego that was trying to figure out a way to communicate to people the idea of false positive and false negative in COVID testing, and what that means, and also trying to help them understand the difference between probability of positive given that the test was positive, probability of having COVID given the test was positive, versus the probability of a positive test given COVID. And so they're seeing these kinds of things, and I'm not sure that what we have been traditionally doing is preparing them very well for these kinds of visualizations that they will encounter. So I see introductory statistics as moving toward being increasingly visual. It's also becoming increasingly multivariable, and this is kind of one of the reasons that the GAZE recommendations included that recommendation about providing opportunities for multivariables, providing students to develop multivariable thinking. They need to be able to investigate and explore relationships among more than two variables at a time. And the graph that we talked about before is just one example of one way of being able to provide students with that kind of opportunity. It's also becoming increasingly conceptual. There's less focus on the procedural fluency aspects of the introductory statistics course, and much more focus on kind of understanding the underlying concepts, and in particular, understanding the role that variability plays throughout the course. It's becoming increasingly computational as well. Simulation now has become an important part of most introductory statistics courses. It's a tool that allows students to not only develop conceptual understanding in a number of settings, but also allows them to solve a variety of problems that were previously kind of beyond what we could have expected them to do. For instance, even just estimating probabilities in situations that are more complex than the simple rules that a traditional approach to probability would give them in the introductory statistics course. And so with the incorporation of simulation, and then also some courses are incorporating simulation-based inference methods as well, the course is becoming increasingly computational. And then finally, kind of last comment here, I see that the introductory statistics course today is becoming increasingly focused on data science. And I put data science here in quotes because there's not, I know there's not agreement on exactly what data science means, but I would bet that whatever data science means to you or at your college, it probably doesn't mean skill using a graphing calculator, that it's not going to be based on that. So if these are, if the GAZE guidelines represent what I would like to do in my introductory statistics course, and these are observations about where we see the introductory statistics course today and where it may be going, my argument is I can't get there if the only technology my students have is this. And so, I want more for my students. And so I'm going to have to push beyond sole reliance on just a graphing calculator. There's just no way to achieve those goals from GAZE and my other kind of hopes and goals for students with just a graphing calculator as my only technology, or no technology. Again, I can't get there if I'm not using technology at all. Now, this argument has been going on for a long time about whether graphing calculators are what we should be having our students use, and there have been lots of arguments about why graphing calculator is the technology of choice at many places. But I'm going to argue that the old arguments don't really apply anymore, that we've heard lots of arguments. So we'll have plenty of time for discussion toward the end, but I'm going to anticipate some of the arguments about why we can't let go of sole reliance on graphing calculators. One of the old arguments that I hear is that we can't expect students will all have access to a computer. And that was an argument that was real and had some basis, but my kind of response at this point is, hello, pandemic. We kind of went from saying that I can't expect students to have access to a computer or a tablet or some way of connecting to the internet to almost overnight saying, well, this is going to be how we're delivering education, at least temporarily. And so we immediately pivoted, and all of a sudden students did have to have access to some sort of technology. The other big issue that people would always raise is the issue of cost. And I agree that I think was a big stumbling block for many, many years, because you used to have to buy statistics software and not only did you have to buy the software, but you had to have not just a computer, but a computer that was capable of running that statistics software. But the argument that I would have now is that really is no longer the case. That cost is really not an issue anymore, because now all you really need is just any kind of device with internet access, because there are a lot of free apps that are available, which we'll take a look at some of those in a minute, but there's a lot of free apps, and even a smartphone can access and use many or most of these free apps. Now, a smartphone isn't ideal because the screen size is so small, but it's workable, and even though we complain about the size of the screen on most smartphones, it's still bigger than the size of the screen on graphing calculators. So that's one issue. And then, I checked yesterday to see what the price of one of these, the kind of the low end tablets that would allow you to have internet access, would allow you to connect to the internet, and the cost is $99.99. So that's less than the cost of a graphing calculator. So I think that we need to kind of rethink this stumbling block of, well, I can't expect students to have to be able to use apps because it's too expensive for them to access that kind of technology. And then one that always surprised me when I first heard it, but I've kind of come to terms with it. The other argument that I hear now often is, well, if I let students use a computer and access the internet on an exam, they're just going to cheat. And maybe that's true. Maybe they will. My response to that, or my kind of counter to that, is that I don't want to let that stop me from using good technology in the course. And if I really believe that students will cheat if I let them have access to technology on exam, then my argument is, my counter would be, so don't use a computer on exams if you're worried about that. That it is possible to write a really good exam that focuses on conceptual understanding and interpretation that doesn't require using a computer. You can use computer output as part of your exam. You can have part of the exam as a take-home that they do outside of class, but you can do reasonable and good things without having students use them on exams if you're really worried about students cheating. So those are kind of my counter to many of the arguments that have been raised to why we can't move away from the graphing calculator in the introductory statistics course. Now, to make my case, and one of the things that we put in the abstract is that I would talk about some of the free things that are available that could potentially replace the graphing calculator in the introductory statistics course. And so I'm going to share with you 4 of these. And I'm going to start with my favorite app collection, my new favorite app collection. Don't tell Alan Rossman and Beth Chance, who are colleagues of mine at Cal Poly, and I'm going to show their apps next. They used to be my favorite, but now they're my second favorite app collection. And this is an app collection called Art of Stats, and I've put the link here, and when these slides are posted, you can also they'll also be in this. This is a set of apps that was developed by 2 textbook authors, but that are not that are not owned by the publisher that publishes their textbook. These are free, open, and freely available, and you don't have to go through the publisher website. They own the rights to these apps, and they are happy to have people using, whether or not you're using their textbook. And I have just found this collection to be just a beautiful collection of apps, really nicely done. If you go to this website, you'll see an introduction to the apps that kind of describes a lot of the apps, but just to highlight the kinds of things that you'll find in this app collection there's one app that's a guess the correlation. It's kind of a game that students can play. This would be one that's on the side of developing conceptual understanding. And what it does is it randomly generates scatter plots and asks students to guess what the correlation coefficient would be for that data set, and then allows them to compare their answer to the actual value. So and you could even use this before you've even talked about properties of the correlation coefficient, and have them kind of discover some of those properties themselves. It has another one that I really like. It's an interactive scatter plot where students can make their own scatter plot just by clicking on the screen and adding points to the scatter plot. And then they can show the least squares line. They can move points around or delete them and see what happens to the least squares line. So that's another one that I think is fun for students to work with. And then they have the standard analysis ones as well. The one that's shown here in the middle, this linear regression one, is an app that does kind of all of the standard analysis. It finds the regression equation and gives you all of the related summary statistics, R squared, and so on. And it will also calculate confidence intervals. You can see on the picture they've shown here, there's the band, a confidence band shown. So it has apps that do some apps that are aimed at developing conceptual understanding, and other apps that are pretty much just kind of standard data analysis kinds of apps. So I find this to be quite nice. There are a lot of built-in data sets, but it also does allow you to put in your own data when you're using any of these apps. Another one of my favorite ones in this collection is this multivariable relationships app, because it is a nice one for doing that kind of trying to provide opportunities for multivariable thinking, it has an app that allows you to create a scatter plot and then subset it by a third variable, like you can see here, to try and reason about, is the relationship between two variables the same or different based on a third variable. And like I said, there are many, many apps. I've just shown a couple of them here. I would encourage you to take a look at them. They're just, in my mind, they're just beautifully done and easy for students to use. They're visually very nice as well. So that's one possibility. Like I said, completely free. All students would need is some way to access the internet to use those apps. Another set of free web apps are the Rossman Chance applet collection that I mentioned before. I know you can't read any of this, but I'm hoping that you'll be interested enough to visit some of these sites after the webinar and take a look. But they have a collection of apps. One of them, for instance, is the one they call Reese's Pieces, but it's an app that shows a little candy machine, but basically it's drawing samples from this collection of Reese's Pieces. AMATYC does not endorse Reese's Pieces, but I'll throw that in there. But anyway, it allows you to kind of set the proportion of orange candies to draw a sample from here. Takes the sample, students see the sample being drawn, calculates the proportion, and then adds that to the plot here. So this is an app that's used to develop the sampling distribution of a sample proportion, and that would also allow students to experiment with changing sample size, changing the population proportion, and seeing what effect that has on the sampling distribution. The screenshot I had here only has two samples, but you could see that if you built this up to add, 100 or 1,000 samples, you would have an approximate sampling distribution that you could work with. They also have similar app for means, sampling from a numerical population. They have a couple of large built-in data sets for this app. But again, on all of these apps, you can also delete the data that's there and put in your own data to use them. This is one where I like this because it shows kind of the three different distributions you might be thinking about or want students to think about. It shows the distribution of the entire population. You select a sample from the population. You can see the little blue dots in the left-hand picture are the observations that happen to be selected in the sample. Then it shows a picture of the distribution for the sample. So we have the population distribution, we have the sample distribution, and then it adds the mean for this sample into this graph that it's been building up. You can see that's the blue dot here is the one that's being added, but then this is building up the distribution of sample means and allows you to calculate the value if you wanted to see what proportion are larger or smaller than a particular value. So again, a nice app for developing the idea of the sampling distribution of the sample mean. And then another one, you'll see this, there are other apps like this, but this is a nice, easy one. This is one that develops an understanding of what confidence level is. Basically allows you to specify a population. The screenshot here is for proportions, but they have other ones as well. And what it does is it takes a sample, in this case, a sample from a population with population proportion of 0.7, sample size of 100, calculates a confidence interval for that sample and plots the interval. And then this is the output you see for doing that 100 times. You can have students do this kind of one by one till they see what's happening, and then have them build up the rest. Then say maybe I do it one by one 5 times and then ask for another 95 to see all 100. And you can see what it's doing here is it's coloring any interval that actually captured the population proportion is colored in green. Intervals that don't capture the population percentage are marked in red. And so you can look at this display and help students come to understand what the confidence level means as well. right, so those are a few of the apps from the Rossman Chance Applet Collection. Again, freely available. Students, there's no cost to students to use these apps. They just need access to the internet, either through their phone or through some sort of tablet or computer device. Two other ones worth mentioning. StatKey is a set of apps that were developed by the Locke family. It's called Locke 5. There are 5 Locks. Robin and Patty Locke both teach statistics and math at St. Lawrence University up in upstate New York, and they have 3 kids, all of whom got PhDs in statistics. So they have five math and stat PhDs in the family, and they put these apps together. Again, they were designed to accompany a textbook that they have, but the apps are separate from the textbook. They own the rights to the apps, and they're openly available to anybody that wants to use them. You don't have to be using their textbook. They have a variety of apps that their focus is teaching introductory statistics from a randomization point of view. And so most of the apps, or the ones that I find that I go to this site for, are their apps. If you include in your introductory course bootstrap confidence intervals, they have really nice apps for doing bootstrap confidence intervals in a variety of settings. And then they also have nice apps for randomization tests, hypothesis tests, again, in various settings. So this is, if you include those things in your course, not all intro stat courses are including them, although more and more are now. If you include those topics in your course, I would encourage you to look at these apps. And here you can see if you're even thinking of including these things in your course, there's going to be no way of doing this with a graphing calculator as your main technology. And then one last set of apps that I want to highlight are the stat prep apps. These were developed as part of the stat prep project. Was an NSF funded project that AMATYC actually was involved in. And as part of that project, they developed what they call little apps for teaching stats. And the nice thing about these, it's not as a robust collection as some of the others that I've shown. And they're more, I think, more helpful for the teaching concepts side of the course than from the doing data analysis side of the course. But the really nice thing about these apps is that they also have activities posted there on this site that could be used, that are ready for use in a classroom, that show how you could use one of how you could use these apps to help your students develop some kind of conceptual understanding of various topics. And these are very pretty as well. As I said, they're just they're not as robust in terms of having the data analysis capabilities of some of the other collections, but I would encourage you to kind of take a look at what's offered here as well. And there's a nice, on that site, there's a nice description of each of the apps and what it does. The other thing that I found here, and if somebody has used these apps more than I have and has found a way to do it, let me know. But they have 2 very large, robust data sets built in, but I have not found a way to put your own, for students to enter their own data or to use something other than the data sets that are built in. And so, but again, they're nice apps, and they have nice activities that are present there as well. All right, and just you can just see, though, I'll kind of talk about a little bit about it. They have The one nice thing I do like is they have a nice sampling feature. They have this little icon here that if you click on that, it will take a new sample. This is using the NHANES data set, which is a huge data set. And you can see that it selected a sample from the NHANES data set and created this graph. If you clicked on that, it would select new sample and you could see how the graph would change. So you could get some sort of understanding of how different samples change the appearance of these graphs. It has, you can specify the response variable, and the NHANES data set has a lot of variables that you could choose from. All of those are built in. Here, what's being plotted is the body mass index of adults. So we have a sample of those values. And then you can specify the explanatory variable. Here, they've specified education, or I specified education. And so you can see it took the body mass index in the sample and separated them out for the different levels of education. And then this also does mention about the multivariable thinking recommendation earlier. This does also facilitate that because it allows you to select a third variable as a covariate. And so, for example, if I selected the smoking as a covariate, you can see that it split them apart now into those that smoke and those that don't smoke. And so I could kind of look to see if the relationship between education and body mass index, if that association is similar for those who smoke and those who don't smoke. So that's the kind of thing that you might be able to do with this. But as I said, I haven't figured out a way to put my own data in here, but they do have, like I said, two very rich, large data sets built in that you might use. All right, well, so that's kind of a quick overview of the free apps. And what I'd like to do next is to get your thoughts and before I try and make the case one last time. I know in this webinar format, we don't have the ability to have you unmute and ask your question, but hopefully I see there's lots of things in the chat. I haven't been able to follow it, but Mary and Julie will help me out and can tell me what's in the chat and we can respond. Yeah.
So we actually have a question in the Q&A.
Oh.
It says, if you could only choose one of the stat sites you showed, which would it be?
Okay, like I said, don't tell my colleagues Beth and Alan, but I would choose the Art of Stats, the Art of Stats apps, because they're really well done. They have everything. I could do everything in the course that I would teach here, except for we do a very short, just 1 or 2 days on multiple regression. They don't have the multiple regression app yet there, but it's listed there up on their site as under development. And I think when that app comes up there, I would be able to use that as, as a single technology. One thing I wouldn't recommend is sometimes it's really tempting because we get excited about all these apps and, oh, there's this one over here that does this, and there's that one over there that does that, and vice versa. And I might find an app, there might be an app on the Rossman Chance applet collection that I like slightly better than the one on Art of Stat for the same one. But I find at the introductory level, having students have to jump and use all these different resources and use apps where they look different and the way you input data is different sometimes, that's just something that can be very confusing or difficult for students. And so I would, if you can find one that would work for you, I would recommend doing most of your work in those apps, and then just going out to other apps if there are things that for things that you want to do that you just can't do with the one you're asking students to use most often. Okay. Another question, let me see.
Someone posted in the chat, they asked for suggestions for where to get real data from.
Oh, okay, so suggestions for real data. So I'll tell you, so this is a site, I'll share a site that I've just discovered in the last few months that has been a real resource for me. It's called studyfinds.org, I believe. Let me, it's either studyfinds, I think it's studyfinds.org, or it could be studyfinds.com. But if you just search on studyfinds, and it's a site that basically just is reviews. In fact, I'm going to stop sharing this screen, and I'm going to bring it up just to show it to you. I'm going to, let's see, let me get that out of the way, because I have found this to be just a huge resource. So I'm going to go to this screen. I had these up just in case you wanted to see any of these, but okay, so studyfinds.org. And you go there, and it's just a summary that they basically, their objective is research in a nutshell. And it's just a summary of studies on various things. And they have a classified family, health, science, weird, even politics and business. And all of these are just short descriptions. Drinking coffee may help treat ADHD, study says. If you click on that, it takes you to just a brief summary of the study. And they typically then at the end or somewhere in here, they'll have a link to the study. And so they have kind of a summary, but then often by going to the link, you can get to the actual study. Well, here you might go to the university release, which would be a press release, and then that will often tell you where the study is. But I've just found this source just to be a kind of a really nice way to find just interesting. You have to do a little bit of work because here's our latest controversy, a poll on whether Will Smith should be charged for slapping Chris Rock at the Oscars. But it has, you have to do a little bit of work because sometimes they'll have a graph or something that will give you the data in their little summary, but they always list the source. And so you may have to go out for that. So anyway, that's, I'm excited about that one because I just discovered that, like I said, within the last month or two, and it's been fun for finding examples, although you can go down a rabbit hole there and end up spending a lot of time looking at things there.
So we do have another question in the Q&A. It says, if a student asks, why do we need n to be bigger than or equal to 30 in the central limit theorem, what would be your answer? And the student is from an Introduction to Statistics course.
Yeah, so the answer there is, I think I would go to one of those apps, and we would kind of look at the sampling distribution of the sample mean. One of the apps that builds up that distribution, and you can start with all of the like the Rossman Chance app has, you can choose what kind of population you want to sample from, and you can choose a very skewed distribution. And you can show, have students, I would have students start with that skewed distribution, take samples of size 5, calculate, and have the app calculate the means and see that distribution, the distribution of means does not look normal. And then just to kind of slowly now have them try it with 10 and then 20, and to see that even for this skewed population, by the time I get to 30, the distribution is approximately normal. So the reason behind, why we do say the 30 or more is that the inference based on the inferences are based on wanting that sampling distribution to be at least approximately normal. And so if I can show them that the relationship between sample size and the shape of that sampling distribution, which is easy to do with those apps, it would be easy to write a nice little activity that had them actually kind of discover it for themselves, that gee, around 30, 25, 30, that's when, even when I start with something that looks pretty odd, it's starting to look normal. Let's see. Yeah, so Kelly is saying something similar. Yeah, she does it in R. You could do it in R if you're using R. You almost all of the the app collections have a sampling distribution of the sample mean kind of thing. So thanks.
Carol responded to your question, Roxy. You
Mhm.
had asked about posting your own data into StatPrep apps.
Mhm.
And Carol said you can upload your own data, click on the data folder icon under the source package drop-down menu, and you'll see an upload feature.
Oh, okay, great. So thanks. I appreciate that. Yeah, I haven't used those much, but they're very nice. And I, you know, in looking at them again over the last week, I didn't see easily how to do that. So thanks. That isn't a limitation of those apps. Let's see.
So
and
there's
I was just going
two
to mention that.
things. Sorry, there's two things in the Q&A. I think they're more okay, so the first one I don't necessarily think is a question, but the second one says, thanks for the links to free apps, but I need to either find or write my own book to use the apps. I realize that I should be using Roxy Peck's textbook, but our budget currently only allows OpenStax, little or no multivariable, little or no tech beyond graphing calculator. How to find OER that is more, I always pronounce this wrong, Gazi?
Oh, Gaze.
Gaze 2016 compliant.
Yeah, so one thing that I will say that is not available quite yet, but that is in the works and should be out very soon. In fact, was presented at AMATYC, the meeting in the fall, is the Dana Center has a grant to develop a kind of an open source intro stat course. They've had an intro stat course materials in the past, but it hasn't been completely free. They got some grant funding to revise that and make it an open source one. I believe that it's it'll be available this fall. So you might watch the Dana Center website. They are going to have an open source curriculum that will be, and they also have the technology to support it in that when they were developing that their open source course, they needed to figure out a technology, and we're trying to figure out whether they should write their own apps. And many of us that were doing some reviewing for them suggested, no, you need to look at those Art of Stat apps. And they actually then contracted with Bernard, who wrote the Art of Stat apps, to kind of adapt them and put in their data sets and things. So they have a version of, they have their own set of apps. It's not called Art of Stat, but they're the Art of Stat apps. So I would watch for that in the fall. I think that's going to be very promising. And as I said, a free, there may be a small charge for the online homework. I'm not sure. They were talking about maybe having to have a $20 a semester charge for the online homework, but that would be, but if you weren't going to use the online homework, then it would be free on that. So that would be one place I would look.
We have another question. Says, I have considered teaching the bootstrap method and wanted to know if you think this is taught in a lot of other intro stat courses.
Yeah, so I think that it's being taught more often now. It's a method that that I think is worth considering if you want to put it in your class now that there's good software. I mean, the drawback for many years is there wasn't good software apps to do it that was accessible at the intro level. But now there are entire courses that take the bootstrap and randomization test as their kind of first pass through inference. I tend to do the opposite. So that one approach says you teach those things, and then you also afterwards you throw in the traditional methods, because they may, if they're going to go take their psychology research methods course in psychology, they're going to have to know how to do a t-test, not just the randomization test. I tend to do the opposite. I tend to do the traditional stuff, because I think if you do that well and motivate it well with technology, you can it is understandable to students. But then I like to cover the bootstrap confidence intervals and randomization tests as here are some techniques that you can use even when those assumptions aren't met. So you have the traditional methods all have, these assumptions that have to be met in order for them to be appropriate. And so I like to kind of follow them up. Well, what do you do if those assumptions aren't met? Well, for confidence intervals, bootstrap, confidence intervals, this is a way to, that you could go. And so I tend to cover them as the kind of an alternative to the traditional. But I think you're seeing it in more and more courses. And if you have the time, I think it is really useful because to provide students with something so that we don't kind of leave them in too many situations where they have to say, well, I know how to do the 2-sample t-test, and I know that I shouldn't do it in this situation, so I just can't do anything. Or my least favorite phrase, I score exams sometimes for the AP statistics exam, and students, they get in a situation where they go, well, I really shouldn't do this, but I don't know what else to do. So I am going to proceed with caution. And then they go ahead and do it anyway. So I like to give them like the simulation, bootstrap, and randomization tests, which are all kind of related. Provide them with tools that allow them to really expand what they can do. So, all right. And I noticed Kelly also put in the chat, I had seen that she had said that when she introduces a new app, she does a little video for students on how to use the app for each new app that she introduces. And I think that's a great idea as well.
I don't see any other. Oh, yep, there it is. Thank you. I just saw it. You got it, Julie?
If you want me to. There was a question. Do you cover one sample test, 2-sample tests, and ANOVA in addition to that?
Yeah, so the course that we have at Cal Poly, we have a number of different varieties of introductory statistics courses. We're one of those places that has Introstat for social science and Introstat for business and Introstat for life sciences and things like that. But yeah, our typical course covers 1-sample test, 2-sample tests, and then we do a very quick coverage of ANOVA, just one way ANOVA, but that often gets kind of short shrift there. If I had to do only one of those, I tried to make a case once, but it didn't fly, to solve our time crunch thing by dropping the 1-sample tests, because I think the 2-sample tests are really important because so much of what goes on involves comparisons, making comparisons. And so if I had to drop them, I would drop the 1-sample tests. But it's easier to introduce the concept of hypothesis testing in the 1-sample setting. But I would do, in my ideal world with no constraints, I might do the 1-sample test for proportions and then move right to to develop the kind of the logic of testing, and then move right into the 2-sample tests.
There was another question. The individual wrote, hypothesis testing is coming up in a couple weeks. If I want to dip my toe into the water into having my students use an app rather than a graphing calculator, which app would you recommend for a simple t-test?
Well, so I would go to the Art of Stat apps, and the Art of Stat apps, their apps are kind of are kind of grouped together, and you'll find there's an app for one mean that does confidence intervals and hypothesis testing. If you're talking about one that just does the analysis part, if you're talking about one that develops the idea develops the kind of the conceptual understanding underneath, then I'd also go there, but I would look at the apps that are under the sampling distribution heading. All right. All right. Well, I guess I have just a couple minutes left. I'm going to go back to my last slide, and then I will. Let's see. Let's see, I'm not sharing my screen, am I? I'm somewhere
ma'am.
else. I somehow got somewhere else. Let's see, share screen. Let's see. All right, so I'm going to make the kind of my case one last time. So just as a kind of a summary of why I would argue that, and I don't have anything against graphing calculators. I think they're good for some things, and calculators. There's lots of things where I pick up my calculator instead of, going to turn on my computer. But the case one last time is, if we want to have students work with real data in meaningful and authentic contexts, exploring multivariable relationships, kind of getting into data visualizations and communicating with them. I think there just isn't a way for me to teach the kind of course that I think students deserve if I feel like I have my hands tied by, by kind of limiting the technology that I can ask students to work with. So anyway, so that's kind of just the summary. And then I think, Mary, you had a wrap up, but I want to thank everybody, especially for those of you that it's dinner time and you're here with us, those on the East Coast. I appreciate it, and hope to see you all in Toronto, hopefully in November.
Thank you, Roxy. We appreciate your time and everybody's time for this webinar. As always, if you have any questions, please feel free to reach out. Otherwise, this recording will be posted as soon as we can get it posted for you. Thank you again.